ladies and gents, what we're going to do is a really quick idea about how to show how different landscapes react to water. All right? Because actually what we've started to realise is that there are different types of rock, igneous, sedimentary, okay, as well as metamorphic, and they all react differently to when there's rainfall. So let me take it right back to the bare bones, and let's make this landscape just rock, okay? So we've introduced a bit of a slope, as you can see, and we're going to just put a little bit of blue paper here to represent the water or the river. Can we get some more blue paper there, please? Thank you. I'll just get my assistant. Can't say beautiful. Oh, she is. I just realised she was going. Of course she is. Alright, so can I have some of the paper? We're doing this in real time, miss. Alright, so here we have the paper to represent the river that this rainfall is potentially flowing into. Let's lift. Here we go. Scenario 1, bare rock and it's impermeable. Alright? In other words, the water cannot get through. It is non-porous. This would be a bit like a granite. Okay? It's a very, very hard rock. So we're going to introduce some water. So what's your prediction? What's going to happen? The water, there's your river, this is your slope, your landscape. What's going to happen? Is it going to get there quickly or slowly? You say quickly, why? There's nothing in the way. Good. All right, so let's just try it. So you can see from the point of the source, it's down very efficiently. There's nothing to stop it, nothing to interrupt it. It's there quickly. Now, I'll be honest, most areas of landscape are not just bare rock. You might get this on the higher altitudes. Okay, but most landscapes have some vegetation, so let's introduce some. So in this case, I'm sacrificing my coat. So we've now got a layer on top of the rock. So what should this do to any rainfall that falls on it? What should it do? Slow it down. Why? What would happen? Give me a word that you might use in sport, that whenever you might pass a ball, but somebody else gets it instead. Right. So there's the word, excuse me, there's a really good piece of terminology, interception of water. So if we introduce the same amount of water at the same speed, we could be doing this more scientifically by tipping a certain volume, but we're doing it sort of anecdotally today. Same amount of water, it gets diverted, it eventually makes its way down, but as you'll notice, not quite as quick as the first time. It was intercepted by the vegetation. By this vegetation, I've chosen this coat because it's a raincoat. It's meant to make water fall off it quickly. So again, not all landscapes are like that. So let's introduce another type again. Here we have something that I think you'll agree is porous. It is permeable, and it's just the right size to make this into a sparkly blue, midnight blue landscape. Now, what's your prediction going to be for the landscape, for the rain hitting it? You think it's going to slow it down? So if we have, now the issue with it is, because it's totally flat, we don't have the interruptions. Now, landscapes are rarely just flat, so let's introduce some little indentations. I can do that in a second, but just changing the landscape, the shape, what's going to happen at now? So you think it's going to slow it down? It's diverted it, and there we have some entering the river. So what you're starting to realise is, first of all, the kind of landscape, if it's bare rock, the water gets really quickly to the river. That's called a short lag time. There's a short lag time between the rain falling and it getting to the river. If you see that the landscape has got layers and strata to it, and particularly if it's porous layers, then it slows down the water and therefore increases the lag time, giving the people in the town and the village at the base of this slope time to evacuate, time to deal with a potential flood. But there are other types of landscape as well. So to show that most landscapes, good for teacher stress as well, most landscapes will have indentations. Then we're going to introduce some hills, some little valleys, again quite natural. The material is porous and impermeable again, so make your prediction. What's going to happen? Slow it down again. Be careful. So we've got the rain. Some of it, as you can see, is soaking into the porous layer because it's changing the colour of the paper. And that water is not reaching the river because it's held up here. It's intercepted here. If there were trees in this landscape, they take in a tremendous amount of water. So that's why if people cut down trees, you basically are making it bare rock again. And as you know, that's the most efficient thing for water to travel over. Okay? So with flooding, we know what causes it. It's when the lag time is short. If it's impermeable rock, you can't really change it. So what you might want to do to stop the flooding is introduce trees, introduce something that's going to potentially hold that water back for a bit of time. If you've got an area of farmland, rather than having it just straight down, you would encourage the farmers to have their contour lines is where they have their furrows, because it literally stops it from getting down to the bottom of the valley or getting into the river quickly. There are some things that cost money, hard engineering ideas, and some things that don't cost a lot of money at all, like planting trees, or just stopping people from even putting their houses in that valley in the first place. So flooding is about people's lives. It's about understanding the landscape that these things happen in, understanding what causes the problem, but also what can ease the problem. Longer lag time, more lives saved. Shorter lag time, less time to run. And ladies and gents, that's flooding landscapes.